All right, this is our last video for the first attempt at the second module's exam. This question says, the combustion of C12H22O11 in the presence of O2 produces carbon dioxide and water. The balanced chemical reaction is shown below. We've got a 1 to 12 to 12 to 11 molar ratio there. How many moles of CO2 are produced from excess C12H22O11 and 8.6 moles of O2? So to answer this question, we don't care about this. We've got 8.6 moles of O2, 12 moles of O2 is 12 moles CO2. So we've got 8.6 times 12 divided by 12. Lo and behold, our best answer for this is C, 8.6. Okay, question number 48. With the balanced chemical reaction, question 47, or in question 47, how many grams of H2O are produced from excess O2 and 9 moles of C12H22O11? Okay, so for this question, what we're looking at is basically, I'm going to write it off to the side here, 9 moles of C12H22O11. We've got excess O2, and we are asked about H2O. So 1 mole of C12H22O11 yields 11 moles of H2O. 1 mole H2O has a mass of 18 grams. So 9 times 11 times 18, I get 1782. There's some rounding there, so our best answer option is answer option B, 1783.5. All right, question number 49. Sodium sulfate, NaSO4, Na2SO4 plus BaNO3 react in solution in a perfect ratio. Which ions remain in solution? Okay, so this question right here, this is a precipitation reaction. So you have to know whether or not these substances are soluble. Now, one thing that's worth noting is barium is in group 2 on the periodic table, so I'm going to put Na2 or Ba and then parentheses NO3 and then N parentheses 3. Sodium is in group 1 on the periodic table. And there are some rules that we can follow with respect to precipitation reactions. If anything pairs up with a group 1 ion, it's going to be soluble. If anything pairs up with an NO3 ion, it's also going to be soluble. Those are some tried and true things. So when you pair up NaNO3, so sodium nitrate, that's going to get an AQ by it. Now, sulfates are a little bit dicier. Barium, that's an ion that likes to make things insoluble. So barium sulfate, BaSO4, is a solid. Okay, so this is going to be the solid that precipitates out of this reaction. Now, what this is asking, though, is this is asking which ions remain in solution. Well, NaNO3, there's going to be sodium. Since that's aqueous, that means that those two things separate from one another. So our best answer option for question number 49 is B. Sodium and nitrate. Okay, sorry, that would be C, B. Okay. Now our last question is a nomenclature question, because nomenclature is super important. RBF is commonly known as, well, rubidium fluoride. Well, if you look on the periodic table, what you'll notice is that rubidium is a group 1 metal. So it has a charge of +1. So then when you think about, and then if you look at fluorine in group 7, that's going to be a -1 ion. So if you look at the answer options, well, answer option B, rubidium-1 fluoride. You don't need to do that because it's not a transition metal. You don't need to declare with a Roman numeral what the charge is. So we're going to go ahead and strike that answer option B from the options. Okay. Answer option C, rubidium monofluoride. Well, there is only one fluoride, but those prefixes, mono, di, tri, we only use those when we're talking about covalent or molecular compounds. Rutherfordium monofluoride. Well, that one's not really a good answer option because Rutherfordium is element number 104. So in addition to that, it has the monofluoride, so that's out. So we're really left with only rubidium fluoride. That has everything that you need because your cation is simply its name, rubidium, and then the anion has the IDE suffix. So A is the correct answer for number 50. All right, well, that concludes a kind of run through of your exam and all of the different parts of it. I hope that was helpful, and I hope you